To study the behavior of a projectile launched at an angle, a launcher using compressed air will be used to give an initial velocity to a projectile. The initial velocity can be varied by giving the pressure tank different charges of compressed air. Initially, a charge of just over 20 pounds per square inch will be used. Pressing the release valve unleashes the compressed air from the holding tank and into the barrel of the air gun, firing the projectile. The central question that needs to be addressed is, at what rate does the projectile drop as it travels through the air on its trajectory? To answer this question, the projectile will be aimed directly at a target positioned 8 meters away and 2 meters above the launcher. The target used will be a toy monkey, which is suspended by an electromagnet. The electromagnet is connected to a switch at the end of the airgun's barrel. As the projectile emerges from the barrel, it triggers the switch, releasing the target from the electromagnet. This assures that the target starts its fall at the same instant the projectile leaves the barrel. The projectile's vertical drop will then be compared to that of the target, which is dropped from rest. The final step is to assure that the barrel is aimed directly at the target. A light source attached at the rear of the launcher shines directly down the barrel to give an accurate line of sight. The room lights are dimmed, and the launcher is aimed at the center of the monkey target. Now for the first trial. Seen in slow motion, the projectile hits the falling target at the sighted location. In order for the direct hit to occur, the projectile had to have dropped at precisely the same rate as the target, which was dropped from rest. For the second trial, a slower initial velocity will be given to the projectile to find if the same result is obtained. To give the projectile a slower velocity, a smaller charge of compressed air will be used. Again, the projectile makes a direct hit. This time, both monkey and projectile drop a greater distance before contact is made. This is due to the slower projectile velocity and the subsequent greater amount of time spent falling through the air before making contact. No matter what the initial speed of the projectile, it always hits the falling target. Both the projectile and the falling target have vertical component velocities which are affected identically by gravitational acceleration.